All right. Let me go ahead and get everyone. Oh, y'all are muted. Cool. Welcome, everyone. We're going to go ahead and kick things off. My name is Annalisa, for those of you who don't know me yet, or am a new face here. I am social and community lead at Atrium. I just joined the team. I am brand new. Really excited to help support all of the amazing programs and initiatives we've got going on. But without further ado, today we've got a really exciting conversation. We're joined here with Cyfrin, and also we already know Raphael as well. But we're going to be talking about building with a focus on security with Cyfrin. And I won't be handling intros for everyone here on stage, but I'll go ahead and kick it off if we could get a short intro. What's your name? What do you do? And we'll get into the conversation.
I'll start off. My name's Raphael, go by Village Farmer on Twitter and X. Work at Atrium as the dev row and just super into hooks and excited to learn from Gio today.
Yeah, awesome. I'm Gio. I couldn't do this anonymous thing. I can't keep up with the multiple personalities, so just Gio. Lead security researcher at Cyfrin. We do security audits, tooling, education, just everything security. So yeah, that's pretty much it.
Awesome. So I'll give you all just a quick rundown of the way this session is going to work today. We are going to get to know Cyfrin a little bit more and how Cyfrin can help you support your Uniswap hook project. And then also we'll get into a Q&A and discussion with Raphael. So we'll get into a little bit more of a technical deep dive. And also throughout this session, if anyone has any questions, feel free to hit the chat. We are live on YouTube and on Twitter. So I will be monitoring all of the chats and we'll make sure that everyone gets the support that they need. But so just for a high level overview, Gio, can you start by giving everyone just a quick TLDR on what Cyfrin is and the work that you all do to support builders?
Yeah, perfect. So yeah, primarily we're, like I said, a security firm. We do security audits. This year I've specialized in Uniswap v4 audits, mainly through the Areta marketplace, subsidized by the Uniswap Foundation. So yeah, a lot of projects come through that. And then like I said, we've sort of got a focus on security in other aspects of the business as well. We make open source tooling. We run the Solid security database, which is used by devs and security researchers alike. There's thousands of findings on there you can filter through and sort of make sure that you're developing safely. And then if you're auditing as well, sort of go there, look for interesting bugs or inspiration if you need it. And then we've got a Cyfrin Updraft, an education platform that, again, we want to teach everyone how to build securely so that when you come to audit, you can have the researchers focus on really trying to find these hard-hitting, impactful bugs and hopefully, sort of keep the industry safe as a result. So yeah, we sort of do all sorts, but security is the sort of part that brings it all together. And I think that's the most fundamental and important part of what we do.
Amazing. And just from your own personal opinion, what should builders understand at a high level when they're approaching security, specifically in Uniswap v4 hooks?
Yeah, v4 it's very interesting, very powerful. Yeah, I think that there's a lot of ways you can do it wrong, especially if you if you take the reins with customer accounting. I'm sort of going straight in, but yeah, be very careful of customer accounting. So I wrote a blog post when v4 came out about the sort of main differences architecturally between v3 and v4, because from v2 to v3, obviously you had this shift from providing liquidity across the entire range to concentrated liquidity. That was revolutionary and really cool. v4 borrows a lot of the v3 concentrated liquidity math, but adds in some new features. One of which is the hook architecture, that whole pattern, which allows for lots of flexibility for the end developers who are building on top of v4. And then the singleton architecture and sort of some of the other new nice bits on top, like the ERC 6909 accounting and things like that. They're also things that are a bit different that you want to be familiar with if you're building or auditing V4 hooks.
Yeah. Amazing. I know. I think I found the article. I dropped it in the YouTube chat. I'll drop it on the Twitter chat as well. And I was going to try and share my screen, but I cannot on this Google Chrome. So make sure everyone, if you're in the chat, make sure you're checking the links. But I will go ahead and dish it off to Raphael, because I know I would consider myself like I have a very light understanding when it comes to, like, I guess the technical deep dives of the topic today. So Raphael, I'm going to go ahead and dish it off to you, and I will be monitoring the chat, and once it's time for questions from the audience, everyone feel free to ask. I'll interject then, but take it away.
Yeah, don't feel too bad. Like, I remember hearing like people could like the Uniswap team couldn't rebuild Uniswap v3 if they tried. So us trying to learn v4 is like all hands on deck. So don't feel too bad.
Yeah, it's tough. Yeah.
I know. Once I can nail down like the explain it to me like I'm 5 for a v4, then I'll feel a lot better. But I'm working on it.
Got you. Yeah, you started talking about custom accounting, so let's just grab the bull by the horns. What are your thoughts on custom accounting? Like, it's kind of a scary place to be. You're kind of getting away from what made Uniswap, getting away from their curve. What do you think?
Yeah, it's it's full on. Damn, we're starting full on. Yeah, it is really powerful. So basically with V4 and with the hooks, so they allow you to sort of inject some custom logic into into the flow of the execution, predefined points, right? Before, after swap, before, after like modify liquidity, these sorts of things. That alone is amazing and really flexible. Allows you to build some really interesting protocols and designs, but it still uses V4 under the hood in terms of the maths that is used for calculating swaps and liquidity and all that stuff. So you're not really straying too far from what has already been developed by Uniswap, and you're just sort of, I guess, adding some sort of sprinkles on top essentially with whatever you're building. As soon as you get into custom accounting, sort of all bets are off. You're taking the reins, and you're in control now. You're in the driving seat. You can completely change the underlying AMM logic. It's no longer it's no longer necessarily what Uniswap has implemented, the invariants that we know and love. So yeah, I mean, there's lots of ways. Obviously, I mean, you're basically just rebuilding your own protocol at this point. Within, again, you have some niceties with Uniswap, obviously the routing and some other stuff, but essentially, yeah, you're building a completely different application with completely different rules.
Yeah. With those new like roadblocks that we have, what safeguards can we use to prevent any vulnerabilities when dealing with custom accounting?
Yeah, I mean, when you get into custom accounting, it's pretty much it ends up needing to be like its own sort of bespoke audit, essentially. Anything that you would sort of try and look for in a, I don't know, whether it's a lending and borrowing or like a vault or something, you basically you need to audit it as if it's anything else, like it's its own sort of bespoke thing. I believe I had some notes here that I wanted to mention about custom accounting, but yeah, I mean, things like reentrancy, unsafe external calls, rounding, precision loss, all of this sorts of things that are normally quite common, and especially things like rounding and reentrancy can be quite hard to identify sometimes. You want to be really careful with those, essentially. And also because Uniswap doesn't provide any sort of like native sort of like protections against these things, so you really have to like you know what you're doing and what your threat model is. You map that all out and make sure you have it straight.
Along with the custom accounting, another one of the vulnerabilities that I saw in this audit doc that you guys did was like dealing with hook data when it comes to custom accounting. Hook data is arbitrary data that comes in and can has its own like security trade-offs. What are ways that we can protect when we're using arbitrary data in our custom accounting?
So the hook data, well, there's a couple of places where things are decoded in the hooks. So typically, you're going to want to validate the length of like some like return data, because for the most part, I mean, when you're sort of like, if you trace through the call into the Uniswap code into the hooks library, that data is going to come from a trusted source, like a contract in your system, in your protocol. If it is, one of the like the externally facing functions and the callbacks, then you have to be a bit more careful, because you don't want like your before swap hook to be exposed and anyone can call it with any data. So typically it's obviously like access control. I can't think of any good reason off the top of my head why you might have it exposed for anyone to call. Like, it should sort of be permission to the pool manager only. But as you sort of build out more complex systems and you have more contracts, it's not just necessarily one hook, it's potentially multiple contracts. Then it can get a bit unwieldy. You've got sort of operator approvals set for not just the other contracts, like I said, and accounting going on all over the place, maybe different permissioned roles between contracts. So I think just making sure that you really lock down the entry points is a great start. And if you haven't, again, sort of drawing on sort of experience and other bugs that we found, if you do have custom logic, like for example, that sort of non-typical reentrancy guards, or perhaps a reentrancy guard that should be applied globally across multiple contracts or certain flows, then you definitely want to make sure that is functioning as you intend, because like I said, with custom accounting, that could be catastrophic. That's just the same as hacking any other contracts like usual. So V4 provides no protection there.
No protection. Oh man. So that was one of my other questions. So there aren't any like reentrancy, or are there any type of reentrancy protections that V4 gives you?
So I'm just actually not. Not that. No, I don't believe so. I don't believe V4 provides any reentrancy protection. That's completely down to you. The thing with V4 is one of the other additions it has on V3 is support for native token. So you can use native ETH now, rather than sort of having that wrapped into wrapped ETH and sort of all pools being ERC20. It provides a really nice currency wrapper library to handle all of that stuff. But the caveat there obviously being that native token, you can sort of have that gets transferred with an unsafe external call, and so you can inadvertently hand off execution to an external address, perhaps, that if done incorrectly or at the wrong point of execution, could open you up to reentrancy. So actually, in fact, it's probably the opposite. It's probably like you have to be even more mindful of reentrancy when dealing with V4, especially if you intend to use the native token in your pools, which, given that it's highly liquid, a lot of people will want to do that.
Cool, never dream. Cool. So talk about the native token. How can we how do we protect our pools from these malicious ERC20s?
So I'd say, as well as sort of having a good idea of the actual smart contract architecture and, like I said, sort of entry points, attack surface that you have, I'd say you also want to be very clear on which tokens you intend to support, which sort of pools and structures of pools, pool keys essentially, that you intend to have interact with your hook, because there's not, by default, there's nothing stopping someone from spinning up a new pool and specifying your hook as the hook that they want to use for that pool, right? So that's another thing that you probably want to validate, well, not probably, definitely want to validate in the majority of circumstances, that calls to your hook are actually originating from a pool that essentially is something that you've deployed or you support, because again, that is effectively, that could be a way of bypassing access control. It's not necessarily your typical only owner type thing, but again, that would be a very good way for an attacker to bypass something like that, and again, wreak havoc. Especially with malicious pools, malicious tokens, because typically they can be worthless, and they can be used in some sort of like an inflation, and basically just extract your liquidity. So yeah, definitely want to validate those as well.
Cool. We have our first question. Yeah, cool. About ERC 6909 with claim tokens. Is the 6909 logic embedded in the v4 core, or is it an external contract?
As far as I recall, it's not sort of embedded to v4 core. There is support for it, but in the sense that they have like I can't remember the exact name of the library. It's maybe ERC 69. I think it may be just 6909 claims or something like that. But as far as I recall, there's sort of like limited support for it in the core, and then peripherally, like it can be added on top either by Uniswap periphery or other sort of integrators and things. Yeah, there's a very good talk from when they were launching v4, or like in the final sort of stages of developing it, where they talk a lot about 6909 and the sort of like roadmap for support. I think the intention is to sort of have that become more of a standard going forward. But yeah, essentially you can use it today. You do need to be aware of it if you are like as a developer or an auditor, like see that being used as a choice of accounting, but it's not like required. It just helps for like I guess you could sort of call it like internal balances. No ERC20s move when you use 699 accounting, which obviously is great for efficiency. Given as well that the singleton architecture means that all the sort of tokens are stored in one contract, but that's not a requirement. You can still do sort of normal ERC20 approvals, transfers, and just completely ignore 699.
And follow up to that, in case of redeeming underlying assets to claim tokens, where exactly are the tokens redeemed from? Is it in the v4 core, or are they transferred to the 699 contract if it's external?
Yeah, so I'm just going to check the library to make sure I get this accurate. But essentially, if the owner of a 699 token or an operator that they specify can burn the tokens, and when you burn them, essentially that just gives you unwraps it, gives you the ERC20 that's underlying, and that ERC20 is stored either in the hook or the pool manager. It depends on how the accounting is done, and so essentially there's not, as far as I'm aware, I haven't really looked at too many ERC 699 implementations first. I'm like questioning myself now, but typically assets are being transferred out of the pool manager or the hook. That's what you want to pay attention to when you're developing auditing. That's pretty much it.
Cool. Thank you, Frontier.
Yeah. Oh, sorry. I was going to say. So it's the deltas that are important. So that's where you'll be focusing, especially with the auditing. So I don't know. Maybe I'll just sort of go ahead and give a brief intro to delta accounting. But essentially, within the lifetime of an operation, a given call to a function in v4, all deltas must be settled at the end, and that just essentially means, if you're taking tokens from the pool manager, for example, in like a flash swap or something, you can do that because Uniswap Flash accounting allows for it. You can do anything. Like you can take all of the liquidity that exists as long as it's obviously paid back by the end, like a typical Flash loan. But yeah, the Flash accounting, Delta accounting just allows you to get kind of creative with how you do that. And I think there's, in the periphery, there's a lot of, I think, like nice sort of patterns and extra sort of like stuff on top that allows you to chain calls quite nicely. But if the deltas aren't accounted, if there's a debt that is owed to, say, the pool manager or the hook that you've interacted with, and that's not settled at the end of call, then everything will revert. And so yeah, pretty much like when you're looking at the accounting, the pool manager and the hook contract itself are what's important, because the hook can sort of, like we said with customer accounting, that the hook can take control. It can sort of tell the pool manager, don't worry about these funds. I'm going to sort of escrow them and account them in this hook. And yeah, that's great for like interesting novel applications, maybe some rehypothecation that you're going to do as part of your protocol, maybe generate some additional yield for your users. But that's basically, you're in control. That's putting those funds at risk if you do it wrong.
Cool. I guess we kind of got a little bit ahead. I'll kind of bring it back to give us a little bit more context.
Yeah, sorry.
Hooks allow for all these permissions, after swap and before swap, and etc. But we also have those after swap return deltas, which is kind of what you were just talking about. These flags are like super important. They allow for the pool manager to know upfront which flags you have enabled. If you don't have, let's say, our after swap return delta flag enabled, what are some vulnerabilities that we can have without having it enabled? And I guess the thought process for when we want to use those.
Yeah, absolutely. So if you have the after swap permission and you don't have the after swap returns delta permission, that will be skipped. It won't pass the return delta. It will just proceed like a normal swap. If you do have the returns delta permission set, but you fail to return the delta correctly, it will just be passed as essentially the same thing. It will be 0. And yeah, on its own, that's not necessarily a problem. But if this is a protocol that expects a return delta to be present, then chances are that's going to break something downstream. There might be a fee calculation or something that expects a return delta to be present when it's not. Then yeah, that can lead to all sorts of sort of like arithmetic issues. Sort of thinking on the lines of like a division by 0 that could result in a revert, which is a DOS vector, a denial of service, or it could just end up over or under sort of crediting. Maybe the protocol or a user might not charge them correctly, essentially. So yeah, it's with these deltas, the main thing that I've seen has been what ends up breaking the fee accounting if they're implemented incorrectly. And I mean, not just exclusive to Uniswap v4, but I think typically, from experience, fees tend to be overlooked. They don't necessarily seem like this mission critical, like breaking issue if they're incorrect. But and I guess it's not like the sort of like meat of the application necessarily in terms of if there was a hack. Would you rather the fees get stolen or the actual funds, like the bulk of the funds, or if they were inaccessible? It's obviously not great, but it's not end of the world. But actually, overlooking them can end up sort of like inflating the severity, increasing the severity, because it can result in, like I said, sort of reverts that potentially are not possible to be recovered from, and then you end up sort of like freezing everything. So yeah, the return delta is very nuanced, very difficult. They might not seem like too impactful if you get them wrong, but they really can be, depending on the specifics of the protocol.
Yeah, it kind of makes sense. Like a lot of things in security, it's normally not one thing, but it's normally a cascading amount of things that lead to major losses.
100%. Yeah, definitely.
When it comes to like permissions that we're not using, should we put any precautions into those? Like ones that we don't expect that we're going to use, but could they come back and affect us in any way?
It can be a good idea. I don't think I'd want to sort of like recommend it as a, sort of like flat rule, because again, you want to be careful not to introduce any sort of DOS vectors yourself. So like maybe, for example, okay, so I think my sort of recommendation for this would be, if you're sort of doing vanilla v4, you're just sort of implementing your permissions, you may be doing a few before after swap or whatever hooks. Probably no. I just said donations. That in fact there isn't any real issue with like having them enabled, allowing them to execute. The reason I use that as an example is because, again, typically, that's a code path that maybe is less explored or reviewed. And in the past, with hacks like Euler, for example, that ended up being a function that was introduced, or like logic that was changed related to donations, that was subsequently used as part of the exploit. So in Vault implementations and other sort of like DeFi heavy stuff, inflation attacks through donation are a big problem, and so you might want to disable them. But for Uniswap v4 specifically, if you're not doing anything like crazy, that's fine. But that's a good example. You could, for example, in the before donate or whatever the hook is, I don't recall off the top of my head, but you could revert there, and then that would prevent any inflation of the fee growth, which may be desirable if your application does depend on the fee growth in some way. If you're implementing some custom incentives logic or something, you might not want that to be changed by someone who doesn't necessarily interact within your system. Typically, I think, I'm not going to say categorically, but I think there's no harm that can be done. It normally ends up working in favor of the LPs. But essentially, as soon as you're ending up building out something more complex, you may want to consider reverting on those unused hooks, but equally just be careful that it doesn't cause other issues if you're inadvertently sort of like DOSing your own protocol.
Yeah, interesting. I had another question. You talk about reverts, and from my understanding, all reverts aren't created equal. And when it comes to like the liquidity modifications, when reverts happen there can be a case where liquidity can be locked. I could be mistaken, but do you have any insight on that?
Reverts are a big source of it was like unhandled reverts in sort of like other logic that you're not necessarily thinking about, right? So like I said before, arithmetic reverts are maybe the most common that I've seen. Incorrect sort of accounting of the fees that has downstream effects. Maybe you get an underflow or an overflow somewhere, division by zero, something like that. That's pretty bad, because especially in the liquidity modification hooks, because then LPs aren't able to withdraw their funds. If you're DOSing swaps, it's not great, because effectively you've got no product anymore. If it's temporary, okay, that's not too bad. Like, you can recover from that. But if you've like reached a state where you can't recover from, then you've got no product. Your LPs can't remove the funds. Like, it's not a great position to be in. So very much make sure that and to be fair, it's not only like logic that is written by the hook developer, within the hook itself. If you're calling out to other contracts, with external calls, perhaps, like I said, you're doing some sort of exotic rehypothecation or something, then if those calls revert, you need to make sure that they're handled correctly, maybe in a try catch or something like that, so that you can, yeah, make sure that you're not just sort of bringing everything down.
Yeah, we have some more questions in the chat. What is your stance on contract upgradability in hooks?
Ooh, this is I think this is like a debate. Just upgradability in general. We could go for quite a while. I'm sort of like not a code is law purist. Yeah, I think it's more nuanced than that. But I do like the enshrinefication that we have in Uniswap, right? Yeah, we have I guess all the way back to the Viper contracts, right? But V2 through to V4, nice sort of isolated new versions. So I like to see that sort of replicated throughout the ecosystem if possible. Having said that, like, I'm aware that, well, especially with V4 hook development, you know, it's difficult, and I think and if you're in the early stages of developing a product, so maybe you're still trying to find product market fit, there's a few sort of, other sort of, what's the word, like back office, like considerations that maybe you need. It might be good whilst you're still sort of figuring those things out to be able to react quickly, upgrade the contract, maybe change some logic related to fees, or, you know, sort of like based on revenue like requirements or whatever it is, like revenue sharing. So yeah, I think in general the simpler the better. If you can launch with like a minimally viable hook and get something out the door, battle test it, you know, don't try and do 100 things at once. I think that would be preferable than building out some crazy you know, revolutionary new product and then just like slapping it behind a proxy and being like, cool, it's upgradable. Yeah, I wouldn't recommend that, ideally.
Yeah, like I can imagine some like weird return deltas where, oh, it's upgradable now. Where are your funds coming from? Like oh, where do they end up after the swap? It could change each time. Cool. Let's see. One of the other things I saw was people aren't importing the base hook when they create hooks. Could you just go in on how important, not important it is to have the base hook imported when devs are developing with hooks?
Yeah, I again, I would recommend it as a sort of rule of thumb. Just use a base hook. Just use like the tried and tested libraries. OpenZeppelin's great. You know, they do a lot of good things for the space. It'll save you a lot of headaches. And to be honest, like, even if you don't, what am I trying to say here? I think if we could sort of encourage people to not presume that even if you're a crack dev, like, you're going to know every way that you might mess up. You know, just these contracts have been audited by some of the best people in the space. You know, been looked at by a lot of eyes, and if that's not good enough, there are also really good references for how to do this stuff properly. So in the other article I wrote most recently, the security considerations, you know, some of the points we've been discussing here for Uniswap v4, I referenced just like base hook. That's what the contract's called. But since I wrote that, I've seen that they've actually added a number of other sort of base contracts, base hooks that you can inherit from that do implement slightly different like features essentially based on v4. So they have like a custom accounting base hook and some other like async swaps base hook and things like this. So yeah, I would definitely encourage people to check those out. There are some cases where perhaps you want some, like, squeeze out some tiny added efficiency, like maybe bytecode size or something, where you're just like, yeah, I'm not going to inherit that. I'm just going to implement it myself, like, really simply. If you can avoid it, I wouldn't. I just, yeah, stick to the libraries, and then, you know, go from there.
Yeah, stick to what works.
Stick to what works, exactly.
We have some other questions in the chat. Yeah. With the singleton architecture, is it possible to use an arbitrary contract to initiate pool manager unlocking, or is there access control around address of the router contract?
No, the yeah, anyone can unlock the pool manager, I believe, and then you just you specify the callback. Well, yeah, essentially. So like in your hook, you'll have like an unlock callback that receives whatever call data comes from the unlock. So yeah, it's not exclusive to the router.
Cool. And a follow up: is it possible that ETH mainnet Fushika upgrade can objectively introduce some opcode level vulnerabilities that might impact the security of the V4 protocol, and by extension the
Yeah, I'm just going to go ahead and say I've not kept up with the changes in Fusaka, so I can't answer that unfortunately. But it sounds like every dev's worst nightmare. So yeah, definitely worth looking into. It's probably something I need to read up on if I have any V4 audits coming up. But yeah, did we see any with the more recent hard forks? I don't think there were any like catastrophic like bugs that arose. Maybe I'm sort of like recency bias. I can't really remember what happened, but yeah, it's definitely good to do due diligence, especially if you are a project that already has a sort of something deployed on chain. Yeah, definitely. I will also go away and do my homework on this at some point. Maybe it's some Christmas reading.
Yeah. Next question: what are the best, in your opinion, Solidity auditing frameworks, i.e. Slither, etc., more geared towards DeFi? And also, is there a base for Solidity template DeFi engineers should be using?
I'd say just keep it simple. Use what works for you. Like sort of find your workflow, and then so like Slither's great. We also have a static analyzer called a Darren, very similar, but sort of architecturally maybe does things a bit differently. But I don't use those too heavily when I'm auditing. I really just try and stick to manual review and then just getting stuck in with testing. So and like with like a Forge sort of template, maybe that's great for if you're doing incident response or sort of bug bounty type thing, but for just normal like auditing, developing, just work with what you got essentially. I'm not a huge fan of Hardhat compared to Foundry, but there have also been some pretty nice improvements with the release of Hardhat 3. So yeah, I think it's just good to hopefully people sort of kept up and they use best practices, so you can just go in and use whatever's there really. You shouldn't really need to sort of bootstrap your own test suite or anything like
that. And then one more question: are you utilizing AI in your audits, and if so, is there a process that you are using?
Yeah, I like to sort of use LLMs as like a rubber duck, like a sort of partner that I can discuss things with. So I don't, I'm not using any necessarily like AI auditing tools or anything like that, but I am, I guess, getting all of my own sort of thoughts out, all my own notes, doing my first pass of the code, looking for things that look weird, suspicious, potentially vulnerable, or even things that I know are wrong and vulnerable, and then trying to sort of like expand from there. I'll take that, chug it into like ChatGPT or Claude or whatever, and yeah, just sort of like see what it spits out. It is very good for low level stuff and math heavy stuff as well. If you're not like if you're not super, I'm not going to say super confident, but if you've sort of like done your best with Yule, for example, or some like really complex math. I audited a pretty intense, like I don't even remember what it was, like a Newton-Raphson approximation for a square root that had some other interesting sort of weirdness going on. It was like this, like some sort of effective price calculation that was used to modify the swap. And so I'd already found some edge cases in the logic that, you know, very specific inputs that I was like, well, hang on, they're not covered by the conditional logic. So what happens when these arise? Is that even possible? And what's the outcome? You know, there was an assumption that, written in the dev comments as well, you know, this is going to, I don't know, be increasing from this value, or whatever the assumption was. But I was able to find edge cases that violated those assumptions, and then with the help of AI, I was sort of like, just, I guess, pulled on the thread and managed to find the full impact of those issues. So yeah, I think it's a good tool, but I wouldn't rely too heavily on it, essentially.
Yeah, I feel like there's like two AI takes. Build really fast and break things. Also like go through everything and talk to it about every little functionality of your code. I'm kind of more on the other side, which is kind of slow, but I get to really know my code base, and when it's time to get an audit, you know, like what to tell them when people have questions about what's going on.
Yeah, I'm really not a fan of heavy like AI dependence. Like, even I've seen some sort of takes where it's like, oh well, the test suite's fine because it's not, you know, production code in the sense that it won't be deployed. But in my experience, both sort of trying to use it and also having to audit projects where it has been used heavily, it's just not a fun time. You know, it's just messy. It's, I think there's too many sort of, like just AI slop, I guess. Too much of that. It just is really unwieldy, and lots of things that are wrong. So like I said, I would just, ultimately you need confidence in your own code, right? And especially for something as mission critical as this, I don't think just sort of prompting, you know, write me the next best Uniswap v4 hook and like full sending it is a great way to go about it. I think obviously, you know, for very specific issues or ideation, I think it's great, but yeah, I would not build fast and break everything and RF everything. You know, like just just too many bad stories and experiences with AI development.
Cool. That kind of answers the next question, which is lastly, since there's a rise in AI and Solidity development, are you finding more issues from this? And what tips can you give developers that are using AI in their workflow?
Yeah, I think I pretty much said my take. I wouldn't discourage people from using it. You know, I think it's a great tool, but just to remember that it's a tool, and just not to have that heavy, or reliance is probably the word I'm looking for. Yeah, just don't have that heavy reliance on it. Use it for what it's good at, basically, and make sure that you're not dumbing yourself down in the process.
Yeah, it's really hard with Uniswap before. There's so much going on, so many moving parts. It's hard to just let it all go. I also don't find it that does too well for what I want to do, but that's neither here nor there.
I think you just have to know what it's good at, and you employ it when it makes sense. Yeah,
piece by piece. I had a couple other questions about Uniswap as we come to wind down. Dynamic fees, very useful in the space, trying to incentivize different behaviors. To use dynamic fees, you have to set a dynamic fee flag. I was never quite sure what that flag represented. Do you have any take on the flag?
Yeah, so there are two flags related to dynamic fees. So the first one is a constant that is present in the Uniswap, one of the Uniswap libraries, the LP fee library, that can be used within like your pool key. So you specify like the currencies, the fee, the hook address when you're deploying a new v4 pool. You have to, it essentially can be used to flip like the uppermost bit in that fee member of the struct. So I guess it's like similar. It's sort of akin to how when you mine the address for the permissions for the hooks, it's the same sort of thing. If this bit is set, then okay, dynamic fee support is signaled. It's active. that alone doesn't necessarily mean that dynamic fees are actually going to be used within a given swap. So there are two ways that you can override the fee. So there's some nuance around the default fee as well that a pool initializes with. So by default, dynamic fee pools have a 0% fee. So if you want that to be effective from like the get-go, from as soon as you deploy the pool, then you do actually need to basically make that happen within the after initialize hook. Otherwise, there is an override, like an admin function that you can call to set the dynamic fee, and that gets queried from the pool manager, and that will be used, like that updates the default fee of the pool basically. However, the other way you can like override that fee is on a per swap basis, and that is typically where I've seen a lot of issues, because not only do you have to have that flag set within the pool itself, but you also need to have that flag within the fee that was returned from the hook. So, say you for swap hook, I don't remember what the function signature is, but you return whatever it is, the delta is the fee. I don't remember, but you basically have to do a bitwise OR with another flag that specifies, hey, I'm returning a dynamic fee, like this is what I want to use. I think it's in the LP fee library as well. It's called the override fee flag, and you do that in conjunction with the fee that you're overriding to. And so that allows you on a per swap basis, like I said, to adjust the fee depending on, I guess, market conditions or some sort of custom logic that you define within your protocol. So really powerful. But if you forget either of those two flags and you're expecting this dynamic fee to be used, it may actually not be, which obviously, again, like we said earlier, goes back to the accounting being thrown off completely and can cause some real impactful issues that maybe you wouldn't have, would assume wouldn't be the case, but really, can break things quite badly.
Yeah. Are there any safeguards that we can have around our dynamic fee if it's being updated from external users?
I mean, the key thing there, I guess, is access control. If you have got any sort of permissioned access to override dynamic fees, or access to that function is critical. You don't want that exposed. I guess on the per swap basis, you want to avoid any sort of manipulation of whatever your calculation is. If you're determining it on the fly, you just have to be careful about how you're doing that, essentially what you're computing. And the other, I had one other point on that, which I'm trying to recall. So I guess it's sort of like dynamic fee adjacent. You might split your, so you've got the Uniswap fee for the whatever the swap fee is, right? But then you've got these dynamic fees, and maybe the hook will take a cut, and maybe you've got some sort of protocol fee that is a percentage of that swap fee that you compute based on the dynamic fee or something. There's sort of maybe 2 or 3 different directions that the fee needs to go, or, in addition to the LPs, and then there's lots of maths that's going to be happening to figure that out. I've seen on a couple of occasions there's maybe a fee switch that's implemented, like a protocol fee or something, a treasury fee, that by default maybe is off, but there is an admin function that's hey, at some point we might have governance call this function to enable the fee switch, essentially. That often gets overlooked as well, again by the same token as by virtue of being related to fees and an admin function, they're typically not as well tested, or they're more overlooked. So I would also say, if you have got custom fee logic, dynamic fee logic that isn't necessarily always going to be active, just make sure that's always really well tested as well within whatever tests you're doing. Make sure that they're all covered, basically, because it might function fine 90% of the time, sorry, 100% of the time, everything's great until you flip that switch, and then suddenly the whole protocol breaks. You've got a complete DOS for everything. LPs can't withdraw, like we said, whatever it is, because actually now you've introduced this additional factor that before wasn't present, and you've got overflows or underflows or whatever it is, screwing everything up. So
another question. If I build a hook attached to a pool like ETH to my token, but use dynamic fees to rebate swaps that buy my token, but only issue ERC 6909, tokens burnable after a custom period, is this something possible?
Geez, it's been a while since I've worked on some like protocol design stuff. But, I mean, it sounds interesting. I would definitely have to sit and think about this. I guess, I mean, if I take it part by part, yeah, you can definitely, make a custom pool with a custom token. You can definitely do sort of like rebates based on dynamic fees, sure. To buy your token, yeah, I guess why not? But only issue 6909 burnable after a custom period. I guess that's the bit I would need to think about, because I don't know. I mean, I guess you could do, maybe you could do some sort of like escrowing or something. I don't know exactly where the tokens will go, but yeah, sounds interesting.
Interesting. Yeah, maybe the fees go into the 6909.
Yeah, I'm not too sure. I'd have to see it, to be honest with you.
Gotta dive a little deeper. Well, that's all the questions I had. Yeah. Hey, Annie.
Surprise! I'm back. Did you have any more questions? Because I do have a question for you, Gio, too. But before we wrap things up.
Okay.
All right.
Yeah,
well, I'll get right to it. But and also, Raf, thank you so much for moderating the technical portion, and I know. Also, shout out to the audience for joining in and asking so many really good questions. I hope we were able to address all of them. So really appreciate that. But I mean, with UHI Cohort 7 Hookathon coming up on Monday, we also have UHI 8 starting, I believe, in January. Applications are open now, by the way. Shameless plug. But and this doesn't have to be security related. It could just be general life advice. But do you have any advice or a word for the builders that are working on their projects right now?
Oh wow. So I'll start technical. So there's one thing at least that I had some notes for that I don't think we got time to touch on. So I'll try and get it through it quickly. Tick math, liquidity, like net liquidity calculations, all that sort of thing. Yeah, be very careful. There's been some really high-profile hacks related to tick logic, incorrect tick crossings, and if you are developing or auditing a concentrated liquidity AMM, essentially focus on how combinations of swaps and withdrawals and series of operations related to those two could be used to effectively mess with the calculation of liquidity. That is performed slightly differently in different protocols. But yeah, if you're doing custom accounting and you're building your own, be very, very paranoid and be very careful. Things get weird at the boundaries, and so you really have to be very careful. And sort of along the same lines, this is kind of like a nice little tidbit that not many people I feel are aware of, and people need to be aware of, is when you're performing operations and comparisons or whatever, you should base it on the square root price rather than the tick. So a tick is like the minimum sort of like discrete unit of like priceness, like price change in Uniswap. I think it represents like a 0.01% change in the price or something like this. But you can have like one tick with multiple square root prices, and so effectively you want to just do everything as square root price based, because again, combined with some of these weird edge cases in like rounding and tick math, it can lead to some like catastrophic issues. Other than that, I guess life advice, I don't know, go like lift weights and get out in the sun. Yeah.
That's amazing. Well, thank you so much, Gio, for joining us and really, really great conversation here. I will be, I know there was like a lot of resources that were shared and mentioned. So I'll be sure to drop those in on Twitter, just right under this video. And other than that, like I mentioned, UHI 8 applications are open now if you are building hooks or you do want to go deeper. And good luck to everyone that's participating in the hookathon coming Monday. Really excited to see what y'all build. But yeah, thanks again, you guys.
Thanks,
Thank
guys.
you.
Really great.
All right, thanks.